About 6 or 7 years ago, I was talking with my dad about something math related, I guess, and during the conversation, he asked me whether the sine and the cosine functions, when plotted in a Cartesian coordinate system, were actually looking like connected and inverted semicircles. I explained to him that that is not the case, but this got me thinking, how would I actually model a function like that? Also, because eventually I wanted to end up with a cool looking math expression in closed form, I only allowed myself to use addition, division, subtraction, multiplication, exponents, raising to a power, taking the absolute value, and all the trigonometric functions. Also, I didn't allow myself to use infinite products or sums. Let's start by defining a circle on the Cartesian plane. These are all the points that are equidistant from the center of the coordinate system. And this just comes naturally from the Pythagoras theorem. Rearranging the equation a little, we get a functional expression for this semicircle. And this is exactly what we need as a base for our function. Now, before we continue, let's quickly discuss how we can scale up and down a function along the coordinate axes. To scale the function along the x-axis, you just divide the input by some constant. And to scale it along the y-axis, you multiply the function by a constant. And of course, if you divide the input and multiply the output of the function by the same constant, it's equivalent to zooming in and out of the function without actually changing its shape. And that's the end of the quick prelude of zooming in and out of functions. Going back to our original goal, we now want to repeat the semicircle shape multiple times. To do that, we can notice that the semicircle function is actually a transformation of the identity in the range between -1 and 1. So what we actually want to do is repeat the identity. Another thing we can notice is that our semicircle function is indifferent to the sign of the identity. In other words, we can either repeat the identity or the identity negated. But how can we do that? So you know how in school they teach you that the arcsine of the sine function is the identity? Well, that is true, but only in the -pi/2 to pi/2 range. Outside of that, the function repeats itself. And that is because the arcsine is always being supplied with valid values from the sine function. So the whole composition is actually defined over the whole real number line. And it looks like this zigzagged curve. We just have to rescale it in the 0-1 range. To repeat the semicircle, we just compose it with the repeating identity and we get the repeating semicircles. Now the final piece that we need is to invert every other semicircle along the x-axis. So we need something like a step function that oscillates between -1 and 1. We can easily get this oscillating behavior by getting an actual oscillating function like a sine or a cosine, a continuous one, and dividing by its absolute value. Dividing by the absolute value of a function basically gives us the sign of the function. And granted, it's not defined where the function meets the x-axis, but I've decided to brush that off for now. However, if you have any suggestions of how can this be done more elegantly, please leave them in the comments. Now we just have to rescale and then multiply our oscillating function with the semicircle one. And we're done. This is actually the function that we wanted to construct. And this is how the final functional expression of the oscillating semicircles looks like. And if you ask me, it looks pretty cool. As an exercise to the viewer, I'll leave the following challenge. Can you design a function using only the operators I mentioned in the beginning that is similar to the one that we just designed, but as the circles are going further from the center of the coordinate system, they are increasing in diameter. So for instance, we can have the first semicircle having a diameter of 2, the second one having a diameter of 3, 4, and so on. I tried this many years ago, but I couldn't do it. And that's it. If you have suggestions, please leave them in the comments. Have a great day. Bye! Oh yeah, and also don't forget to subscribe, like, share, comment, Patreon, and PayPal me.